Basics of Statistics, Part 3.
Probability. When tossing a coin, the probability of landing on heads or tails is 1 out of 2 or 50%. When rolling a die, the probability of getting a 3 is 1 in 6 or 16.7%, which is the same as the probability of landing on any other number on the die. So we can define probability as the chance that an event will happen and show it as P parentheses E. One basic rule of probability says that the probabilities of all possible outcomes should add up to 1. These probabilities that came from calculations are called theoretical probability. And if we figure out probability from experiments, it's called experimental probability. For example, if you toss a coin 100 times and it lands on heads 47 times, the probability of getting heads for this coin is 47% or 0.47. Now, if you want to find the probability of rolling a 1 or a 6 on a die, you can calculate it by adding the probabilities. In this case, that's 2 out of 6 or 1 out of 3. We can also write it as P1 union 6 equal to 1 of 3 or 33%. Remember, we're talking about two events on the same die that can't happen at the same time. Now, if you roll two different dice, we have two independent events. And to calculate the probability of rolling a 1 and a 6 at the same time, we multiply their probabilities. In this case, that's 1/36, or about 0.028, which is 2.8%. We can also express this as P1 intersection 6 equals 2.8%. These kind of probabilities are called combined probability, which is presented by the union symbol for, or, and the intersection symbol for, and. Let's find out. What is the probability of rolling a number less than or equal to 2, or getting an even number on a die? One important thing to note here is that 2 is included in both event A and event B, creating an overlap. The probability of A is 2 of 6, while the probability of B is 3 of 6. We also know that the probability of 2 alone is 1 of 6. In this case, the P at union PB equals the probability of event A plus B, minus the probability of 2, which is 66.7%. Okay, let's have another example. What is the probability of getting 8 in sum when we roll two dice? First, I need to explain a stochastic variable, which is a variable that can take on different values due to chance or randomness. Here, 8 in sum can happen in 5 different ways. Let's look at all 36 possible combinations from tossing two dice. And it shows that the probability of 8 in sum is 5 of 36. If we examine frequency of all the probabilities for the sums of two dice, we can discover that they are normally distributed. Thank you for watching.